Hello and welcome to a lesson on permutations. And I'm going to preface this with saying that this is going to be the first time that I'm teaching permutations in class, so I am very rusty on these, and this video may be a little rusty. There may be some mistakes, so if you find those, let me know. So first thing we need to talk about is what is a factorial, because we're going to have to use factorials with our permutations and then our combinations. So the definition we're going to use for a factorial is the product of positive integer n and all the numbers below it. So we're going to look at a number, and then we're going to multiply all the numbers below it that are positive integers. So this is represented like this. So if our number is n, our next number is n minus 1, and then n minus 2, or we just represent it with this. It's n, and then that exclamation mark means factorial. So this part here is read as n factorial. So a couple examples we have here. This is 3 factorial, and then we see the breakdown of what that means. It means we take the 3, and then we do 3 minus 1, which is 2, and then that number minus 1, which is 1, and then we multiply those together, so we do 3 times 2 times 1 to get 6. And then we have 8 factorial, and it follows the same path. We just do 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, and we put that in the calculator, and we get 40,320. So you can see how these factorials can get pretty big pretty fast because of the multiplication. And remember, these are positive integers. We don't want a 0 in there because 0 is not positive or negative. And secondly, if we multiplied by 0, we just get 0 every time. So we want to avoid doing that. Make it easier though, wouldn't it? So now let's start talking about permutations. And I struggled with permutations and combinations whenever I was in school. It was always trying to figure out order, because for permutations it's an arrangement of objects in which order is important. So the order is important here. So for our first example, we're going to look at the number of permutations of letters A, B, and C. So we're trying to figure out the order that we can put the letters A, B, C. And the order is important, so we can't be having duplicates. So the way I'm going to do this is I'm going to look at the first letter. So I'm going to organize this by the first letter. So I'm going to have an A section here where A is going to be the first letter. So that means I'd have A, B, and C. And then if A is first again, I can't have B second, so I have C second and B. So I have two options there when A is my first letter. B is going to be my first letter, so we have B, A, C. And then we'd have B, C, A. And then finally we have C at the front, so we'd have C, A, B, and then we're going to take that cab all the way to C, B, A. So these are the number of permutations. We have 6. So there are 6 ways that we can order these letters A, B, and C. Now some formulas to help us. So a lot of these are done with the formulas. They're not done written out like this, because if you're using some bigger words, like if I said to order supercalifragilisticexpialidocious, you don't want to do that by first letter. You'd want to use a formula, because that's a lot of letters, and I'm not going to try to spell that word. If you don't know what that word is, oh boy. So, our two formulas we're going to use, one on the left talks about the number of n objects is given by, so we're just talking about a number of objects. just like we did in the last one. We've got some objects and we try to find the order. And that formula is NPN, n permutation n, and that's just the n factorial. So if we have 5p5, that just means we're going to do 5 factorial. So 5 times 4 times 3 times 2 times 1, and we get 120. So we have the number of n objects taken r at a time, where r is less than n. So now we're looking at something where we've got choices, we've got a bunch of objects, and we want to make a bit of a choice here. We want to place them in a certain way. So that's represented with our NPR, which equals n factorial divided by n minus r factorial. So what we're doing is we are kind of throwing out some of those choices here when we subtract that time. So if we have 5p2, 5 is my n, 2 is my r. So that means it's going to say 5 factorial divided by 5 minus 2 factorial. We got to simplify the parentheses, so 5 minus 2 is 3. And then we take our 5 factorial and we get 120 again, because we just did that over there, and then we divide that by our 3 factorial, which if you remember from the previous slide was 6, and then 120 divided by 6 is 20. So there are 20 ways there. Now we're going to do a couple of examples with words. So it says, how many ways can you arrange the letters in April? So we have to first determine which one of these formulas we're going to use. And also as a check, to see if you're paying attention to the video, there is a way that your calculators can do this for you, so you can check your work whenever you show it all out by hand. And if you ask me during class, I will show you how to do that on the calculator. If you don't ask me during class, that tells me that 1, you just don't want to know how to do it, or 2, you're not listening to the video. So here we go. How many ways can you arrange the letters in April? So we're not having any real choice here. It's just how many ways can we do this object? So that is going to be an NPN. And then we look at all the letters in April. There are 1, 2, 3, 4, 5. So it's going to be 5p5, which is equal to 5 factorial, which what we saw from the last slide was just 120. Your calculator can also do factorials for you, and if you want to know how to do that, you can ask me as well. And our final example here says we have 8 runners that are competing in the 100-yard dash, and my English was terrible on this. So in how many ways can they finish first, second, third? So this is one where we're trying to put them in a specific first, second, third. We're trying to figure out who is going to go where. So that means we have to use our NPR. So that's 8p, and then we have 3 places. So we have 8 runners in 3 places that we want to put them. Remember that your R has to be smaller than your N. That's a good way to check to make sure you're putting numbers in the right spot. So this turns into 8 factorial divided by 8 minus 3 factorial, which is 8 factorial divided by 5 factorial. And we could write all the numbers out. We could just do it in the calculator, but I'm going to do this. So I'm going to just change this into 8 times 7 times 6 and figure out what that is, which is 336. So again, I'm going to ask you after you do this video, where did this part come from? See if you can figure it out. If you can't, then you need to be asking me, where did that come from? Again, we got some tricky things in here in this video. That means you actually have to be a bit more interactive. So that's the end of this video. I'll see you later.